Hi everyone, in this tutorial we are going to look at another funky case of needing to kind of adjust our 2 to the n plus ez rule. And in this example we'll specifically think about how cis-trans isomerism of a ring structure will play a role in determining number of theoretical isomers. So this molecule that we're looking at does have asymmetric centers. We're going to label those 1, 2, 3 asymmetric centers. These two over here in darker blue are not asymmetric centers due to the symmetry about the ring. They are still, however, cis-trans stereocenters, okay? And that's going to be important to consider. Now, we so far have said there's 2 to the 3 asymmetric centers, but notice how this is also an easy double bond. We're going to have to add 1 to our calculation for that. If you identify a ring that has cis-trans isomerism, you will then also add 1 for each of those rings with the cis-trans isomerism to your calculation, okay? That's important because you could have that ring have a cis relationship between those substituents or a trans relationship. And when you add 1 to your calculation, you are accounting for that cis-trans. Remember, because 2 to the 1 would be 2. You're accounting for the cis and the trans. So here we have 2 to the 5, 2 to the 5th power, which would be 32 possible stereoisomers. This scenario, again, is you have a ring with cis-trans isomerism, and we have to incorporate that into the calculation. And in my mind, I almost treat it like an easy double bond. This double bond could be E or Z. This ring structure could be cis or it could be trans. Hence why we put those numbers in our calculation to account for the total number of possible stereoisomers. Lastly, one note here, this double bond is not capable of EZ isomerism because of 2 of the same priority atoms on the double bond.